thing that we're going to address here, looking at the CAN lab and thinking about it from last Wednesday, we talked about it, we kind of rushed through a few things. So to clarify a little bit, on the CAN lab, we had a whole bunch of different columns of calculations that we had to do on Excel, correct? So on Excel, the last two columns was the surface area divided by the volume, and then the height of your can divided by the radius of your can. So from these two, you'll have these two data columns here. And the entire point of this lab is we want to find the largest volume for the minimum surface area. So the least amount of metal or surface area on our can, but the most amount of volume. From your three cans, you should find one of them that fits these two conditions here better than the other two. And based off of that, look at what your height divided by radius value will be. And from that, you should be able to make some kind of prediction on what the optimal height versus height and radius ratio is. And once you have the optimal height-radius ratio, then, this is the extension part, you are given a task of if you have a volume equal to 1,000 cubic centimeters, you want to find what the optimal surface area would be for that case. Okay. If you are working on this lab, which is due when? Thursday. If you're working on this lab before Thursday and you are getting stuck, you can come in any day after school. You can come in Wednesday for math, and you can come in Thursday morning. Okay? So that is all I wanted to talk about with the CAN lab. Looking at our week, today we have review, tomorrow we have review, and what is on Wednesday? Our test for rational functions is on Wednesday. So, to start off our review today, I do want to do a rational functions word problem, one similar to the ones that we have done before. So for this word problem, we have two people. We have Tim and we have Tina. And Tim can do 3 loads of laundry in 4 hours. And together, Tim and Tina can do 1 load of laundry in half an hour. And we want to know how long it would take Tina to do 2 loads of laundry. So if you could take a few moments, try and work this one out. If you need to, look back at your notes for this. I believe the notes for this was 7.3 day 1, if you need to look back at your notes. But while you are working, I will pause our recording. Now that we've gotten a little bit of time, I could have row 3, person 2. Could you tell me how you set up this problem? Okay, so the first thing you did was loads per hour, which is basically just setting it up with the rates. So I'm just going to formally set it up. For Tim, we have 3 loads per 4 hours. With Tina, we have 2 loads in X hours. And then both of them together will give us 1 load in half an hour. So, if we remember, the sum of the individuals gives us the total. So if we just add these first 2 rates, they equal this last rate here. The first thing that I would like to do here is I have a fraction within a fraction, and I want to convert that to make it easier. So if I wanted to change this so that it's just a simple fraction, how could I do that? Turn and talk to your table partner. Try and discuss, what do we have to do? All right. We've had a little bit of time to turn and talk. Who is confident and they know how to reduce this fraction a little bit? Maddie, can you help explain to us?
So 0.5 goes to 1 twice.
Yep. So this will be 2. And so you can say 1/2 is the same thing as 0.5. And how many times does 0.5 go into 1? Twice. So you can just say that this is 2. Otherwise, if you were looking at this as just fractions, technically this fraction here is 1 divided by 1/2. If you're dividing a fraction, it's the same thing as multiplying by the reciprocal, right? So this is the same thing as saying 1 times 2 over 1, which is just 2. So you can do it either way. But overall, we end up with this right here is equal to 2. So if we have this slightly simpler equation here, what would be the next step? Row 3, person 6, comes back up to Greta.
So then I tried it like a different. I just kind of multiplied it by 4x each in the numbers.
Okay, so you multiplied this by 4x, and this by 4x, and this by 4x. So then what did you end up with?
Well, so I ended up with, I got 12, oh, sorry, I got 3x in the first one.
Okay.
And then I got 8 in the next one. Then I just had 8x.
Equal to 8x. And so if we multiply everything by 4x, then that works. And we no longer have a denominator, which is nice. So if we look at this here, and we want to combine like terms, we would just have to subtract 3x from both sides. So we would end up with 8 is equal to 5x, or x is equal to 8 over 5. Some people might have gotten something like 4 over 2.5, but basically this is approximately 1 hour and like 36-ish minutes, I believe. So any of those forms work, especially if you were not using a calculator. You might have done this in a completely different way. As long as you have gotten to this answer and you understand the process that you used, you may use that process. I'm not going to tell you that you have to do it one specific way. All right. For the remainder of the period, what we are going to do is we're going to do a formative quiz just so that you yourself get a better idea of where you are currently with the material that you'll need to know on the test on Wednesday. Okay? So with that in mind, because we will be using paper and not Notability, I will end the recording here.